Hey guys, I'm sorry I can't be with you today, but fortunately I can teach you adding and subtracting rational expressions anyway. So for those of you who were here yesterday, which was April 6th, you've already done this first problem, but for those of you who weren't, make sure that you go through it. If you were here yesterday, feel free to skip ahead to the next problem. So with adding and subtracting rational expressions, just like adding and subtracting normal fractions, the main thing to focus on is getting the denominators the same. I'm sorry, it looks like I'm working in a dark room, but I am. So getting the denominators the same. Okay? So just like if you were adding together, let's say you were doing 1/2 plus 1/3. You can't add those together right now because they don't have the same denominator. But the way you could get them to have the same denominator, 2 and 3 both happen to go into 6. So you can multiply the bottom and the top by 3, because whatever you do the bottom, you have to do to the top. And this bottom and top by 2. And then all of a sudden you've got 3/6 plus 2/6. And now you can add them together. And of course, when you add fractions, you just add the numerator. So that would be 5/6. And that would be your answer. So it's similar when you're doing rational expressions. One thing that I taught my students last year was this thing called the butterfly method. So if we're trying to get x plus 6 and x minus 2 to be the same denominator, the biggest common denominator or smallest common denominator is just going to be the two of those multiplied together. So we're going to take x plus 6, multiply it by the top and the bottom, and then x minus 2, multiply it by the top and the bottom. It also kind of looks like hockey sticks. Okay? So when we do that, we're going to end up getting 3 times x minus 2 on top over x plus 6 times x minus 2 on the bottom, just like that. And then on the next one, we've got 7 times, this time we're going to add or multiply both the top and the bottom by x plus 6. So it's going to look like that. And of course, you don't want to cancel what you've just added in, because then you'll just undo what you already did. Okay. All right, so it's simpler to add your numerators at this point if you go ahead and distribute your numerators. So if you do that, you're going to get 3x plus 6 over x plus 6 times x minus 2. I'm sorry, it should be 3x minus 6. And then plus 7x plus 42 over x plus 6 times x minus 2, like that. Okay, now it's easy to just add your numerators together. So you're going to get 10x plus 36 all over x plus 6 times x minus 2. And you can leave your denominator factored like that. You don't have to FOIL it out. And so then your restrictions are just going to be whatever makes the denominator equal 0. So that's going to be x cannot equal -6 or 2. Okay? Sure, my lines are right here. All right, let's do another one. So on your next page, you've got the you try problem. If you want to pause it and try it on your own and then check your answer, that's a good idea. But if not, we'll keep going. So we've got to get our denominators to be the same here also. And of course, the simplest common denominator is just going to be n plus 1 times n minus 7. That's the way to make it the easiest. So I take this and multiply it on the top and the bottom, and this and multiply it by the top and the bottom. So I'm going to get 7n times n minus 7 over n plus 1 times n minus 7, just like that. Plus 8 times n plus 1 over n plus 1 times n minus 7, just like that. Okay? All right, so now I need to simplify my numerators. So that's going to be 7n squared minus 49n over n plus 1 times n minus 7 plus 8n plus 8 over n plus 1 times n minus 7, just like that. And then all I have to do is combine my like terms in my numerator. So just adding straight across, I'm going to get 7n squared. Negative 49n plus 8n is going to be negative 41n plus 8 over n plus 1 times n minus 7. Okay, so that's going to be your final answer right there. And then, of course, your restrictions would be n cannot equal negative 1 or 7, because that would make the denominator 0. Okay? All right. So in example 2, we add in a little bit of difficulty with the fact that you're going to have to factor first. The first two you didn't have to, but you do in this one. Fortunately, they're not that hard to factor. So the first one, if you need two numbers that multiply to equal 4 and add to equal 5, well, that's 4 and 1. So your first one's going to be x plus 1 times x plus 4. And then the second one is going to factor into 3 times x plus 1. So this time it's going to be a little bit more complicated to get your common denominator. So what you want to ask yourself is, what does each denominator have that the other one does not have? Okay, so in the first one, it's got x plus 1 and x plus 4, but it doesn't have a 3 that the other denominator has. So that means we're going to have to multiply the top and the bottom for this one by 3 so that they can be the same. So now you want to ask yourself, what does the first one have that the second one doesn't have? And that's going to be the x plus 4 right there. Okay? All right, so hopefully that made sense. So ask yourself, what does each denominator have that the other one doesn't have? And then give it to the other denominator. So this is going to be 1 times 3 is 3. And then I like to put my constant in front. So 3 times x plus 1 times x plus 4. Okay, and then if I multiply 5x times x plus 4, I get 5x squared plus 20x over 3 times x plus 1 times x plus 4, just like that. Okay, all right, so now I've got common denominators. So now all that's left to do is to add my numerators together. So that's going to be 5x squared plus 20x plus 3 if you put everything in standard form. So there's your final answer. So your denominator stays the same, just add the terms in your numerator. So then, of course, your restrictions on x would be what makes the denominator 0. So x cannot equal negative 1, and it can't equal negative 4. Okay? All right. So again, if you want to try this one on your own, go for it. Pause the video. If not, we'll keep going. So this one's going to be a little bit trickier to factor, but the first thing you can notice is that you could pull a 5 out of here. So let me pull over and factor this one for a second. So if you pull a 5 out of there, you're going to be left with n squared plus 7n minus 8. Okay, and then it's going to be a lot easier to factor this. So you just need two numbers that multiply to equal negative 8 and add to equal positive 7. So that's going to be 8 and negative 1. So this actually factors into n plus 8 and minus 1 with that 5 at the front. Okay, so not too bad. All right, so if we change this one up here, got 5 times n plus 1. So that's what that numerator factors into. Then what we just factored, so 5 times n plus 8 times n minus 1. Okay, and then 7 over 3n, which is what we started with. So again, you want to ask yourself, what does the first one have that the second one doesn't? And the answer to that would be everything, right? The second fraction doesn't have a 5, an n plus 8, or an n minus 1, so we're going to need to multiply all of that in together. Okay, so 5 n plus 8 n minus 1. And of course, we're going to multiply that on the top also. And then this side over here doesn't have the 3n that the second fraction had. So we're going to multiply that. And I don't care if you put it at the front or at the back. It doesn't matter. Okay. All right. So this would be the same thing as, let's see, let's leave our 3n alone for right now. And we'll do, we'll change this back to 5n plus 5. We can change our 3n times 5 to 15n if you want, just to keep things a little less crowded. Okay. And then up here, 7 times 5 is 35 times n plus 8 times n minus 1. On the bottom, I'm going to change that 3n times 5 to 15n times n plus 8 times n minus 1. Okay? All right, so still not done simplifying. I'm going to have to distribute this 3n to the 5n plus 5 to be able to simplify this, unfortunately. So bear with me. I'm going to go over here. So 3n times 5n is going to give me 15n squared plus 15n. Okay. And then still got my same denominator, 15n times n plus 8 times n minus 1. Okay. And then I'm going to go ahead and multiply 35 times n plus 8 just to get that together. And then I'm going to have to end up multiplying all of it by n minus 1. Excuse me while I get my calculator out. So 35 n plus 35 times 8 is 280. Of course, all that is still times n minus 1, like that. And then on the bottom, you still got your same denominator, 15n times n plus 8 times n minus 1, like that. Okay, so still need to multiply these two together before my numerators are totally simple. I know this is a long problem, so 15n squared plus 15n. Okay. All right, so let's do some FOILing. So 35n times n is 35n squared minus 35n plus 280n if you keep FOILing. So 35n times negative 1. So negative 35 plus 280 is 245n. And then 280 times negative 1 is minus 280. So all I did was FOIL those together. Or box method if you like that. Okay, whew, all right, now I think I'm ready to do my final answer. So I can add 15n squared to 35n, and I get 50n squared. 15n plus 245 gives me 260n, and then I've got that minus 280 right there, over 15n times n plus 8 times n minus 1. So my restrictions are going to be what makes my denominator 0. So that means that n cannot equal 0, it can't equal negative 8, and it can't equal 1. Okay, so those restrictions are correct. Now, there's one more thing you could do. If you wanted to factor out a 5 from the top and the bottom, you could do that. So basically, you would be dividing each one of these by 5. So if you pulled that 5 out, you'd get 10n squared. Let's see, 260 divided by 5 is 52. And 280 divided by 5, negative 56. Over 5 times that 3n that would be left, times n plus 8 times n minus 1. Okay, so if you wanted to cross those out and just have this as your final answer, that's also correct, and probably more correct because it's the simplest version. So hopefully that's helpful to you. Okay, all right, let's keep moving on. We're on the last page. This time we're subtracting. The process isn't any different except that you're just subtracting this time. So, all right. So let's factor first. We've got 7 over 3 minus 8 times, let's see, biggest number that goes into 12 and 8 is 4. So 3x minus 2, just like that. So ask yourself, what does the first one have that the second one doesn't? And that would definitely be a 3 on the bottom. And then what does the second one have that the first one doesn't have? Well, that would be both 4 and 3x minus 2. So just like that. Okay. All right, so let's start multiplying out our tops. So if I distribute 4 to 3x and negative 2, that's going to give me 12x minus 8, and I've still got that 7 that was originally there. And I'm just going to, I'll probably multiply the 4 and the 3 together just to be simple. So 12 times 3x minus 2. I'll leave that alone for right now. Okay, and then minus 8 times 3 is 24. And then still got the same denominator since that was the point. Just like that. Okay. All right, so I'm still not completely simplified. I need to distribute the 7 in there. So that gives me 84x minus 56 over 12 times 3x minus 2 minus 24 over 12 times 3x minus 2, like that. Okay, so now I can combine like terms on top. And so we're doing 84x minus 56 minus 24. So negative 56 minus 24 is negative 80. So 84x minus 80 over 12 times 3x minus 2, just like that. Okay, now hopefully you're thinking that all of these, 84 and 80 and 12, are all divisible by 4, actually. So you could pull 4 out of the top, and you'd have 21x minus 20. And if you pull 4 out, you've got 3 times 3x minus 2, because that 4 and the 3 are 12. So those will cancel out, and your final answer would be this right here, 21x minus 20 over 3 times 3x minus 2. Okay, so that means your restriction is just that x can't equal 2/3. Okay, all right, so we've only got a couple more. I tell you what, I want you to try the You Try on your own. And if you have questions about that one, just for brevity of the video, I'm going to skip that for right now because I think that you can do it. So remember to factor first and ask yourself what each side is missing that the other one doesn't have, okay? Or each one has that the other one doesn't have. All right, so let's do example 4 together, and then I'm going to let you try the last one on your own also. Okay, so factor first. We've got 5x minus 4 on top, okay? On the bottom, I've got 2x squared plus 3x minus 9. So I'm going to factor that. Let's see if I can find some space. Let's do it over here. So 2x squared plus 3x minus 9. So I need two numbers that multiply to equal negative 18 and add to equal 3. So that's going to be 6 and negative 3. So 2x squared plus 6x minus 3x minus 9. Pull a 2x out of here and I'm left with x plus 3. Pull a negative 3 out of here and I'm left with x plus 3. So completely factored, this is going to be 2x minus 3 times x plus 3. Just good to know, so I can put that on the bottom. Okay, then I've got this x plus 6, which fortunately doesn't factor, but my bottom does. 5x squared plus 19x plus 12. So let's figure out what that factors into. So I need two numbers that multiply to equal 60 and add to equal 19. So that's going to be 15 and 4. So 5x squared plus 15x plus 4x plus 12, just like that. Pull the 5x out and you're left with x plus 3. Then pull a 4 out and you're left with x plus 3. So you've got 5x plus 4 and x plus 3. So those are your factors for the bottom. Okay, so what's fortunate here is that they both already have an x plus 3, right? So there's only one thing that each of them has that the other one doesn't. So this side needs that 2x plus 3 that we've got on the bottom on the first fraction. And this side needs the 5x plus 4. Okay? All right. So let's do some FOILing on top. These are complex conjugates, so that's kind of cool. So 25x squared plus 20x minus 20x is going to go away. So that's what happens when you FOIL that one out. Okay, if we FOIL this one out, we're going to get 2x squared plus 3x plus 12x, so that's plus 15x. Plus 6 times 3 is 18. Okay, just like that. All right, so now all I have to do is combine my like terms on top. So remember, when you're subtracting, that changes all your signs over here. So remember, when you're combining like terms, be really careful about the subtraction in the middle. So 25x squared minus 2x squared is 23x squared. And then negative 16 minus 18. I'm going to write that last. I'm going to put the x term in there first. So this is essentially minus a positive 15x. So I have to put that second. And then I can do negative 16 minus 18. So excuse my brain while I do that in the calculator. Negative 34. Then I'm going to leave the bottom the same. Okay, so that's going to be my final answer. Just like that. And so my restrictions are going to be that x cannot equal negative 4/5, can't equal negative 3, and it can't equal negative 3/2. Okay? All right, so that's adding and subtracting rational expressions. I hope that was helpful. Try the last one on your own. If you have questions, save them for tomorrow. I will be back and we'll spend a lot of the class period going through it and making sure you guys are comfortable with this, but I wanted to give you a head start on it. Okay, I'll text your homework assignment to you, but it's going to be most of 4 or 5. Okay, all right, have a great day. I'll see you on Wednesday. Bye.